Hi, welcome back to PSLE Math Heuristics lesson. Today we are going to look at a method which is called speed distance timeline model. So this method is used to solve speed problems, and this method is also a major method. It will take a few lessons to cover the entire method. So with this method, you should be able to solve many speed problems. I will not say all the speed problems, but you should be able to solve almost many of the speed problems. So how do we exactly draw out this speed distance timeline? So let's look at the problem, and then we're going to visually draw out this problem. Now, Mr. Ong wanted to travel from town A to town B. So there's a start point to the end point. After traveling 3/5 of the journey, which is the distance. So when you have a speed problem, there are three things that you'll be looking at: the distance. You also have to look at the speed, and you also have to look at the time taken. So in your speed problem, you will always have these three, right? These three things inside. So Mr. Ong passed a lorry, right? Passed a lorry, and that was traveling in the same direction. And then Mr. Ong reached his destination 2 hours later, and the lorry was still 60 kilometers away from him. So in this problem, you can see there are two things moving, right? A person, Mr. Ong, and you also have the lorry moving. So when you look at a speed problem, you will always need to think about who is faster, right? Who is slower. So in this problem, you can see that Mr. Ong is faster. So when you are faster, then you will need to understand that you will take a shorter time to travel because you are faster, and also because you are faster, you will also travel a longer distance, right? If you are faster, you travel a longer distance using a shorter time, and your speed will be higher, all right? Higher speed than the slower person. All right, so if the lorry average speed, right, the lorry average speed was 60 km per hour, find the time Mr. Ong left town A if he reached town B at 4:15 p.m. So you can see that the entire problem is quite hard, right? If you try to solve it without any method, or you try to use your own capability, right, to solve it, you find that you take a long time, or sometimes you might not even solve the problem. So the best way to do this is to use a method, is to use what you learn, is to apply your method, which is to draw a speed distance timeline. And again, like model drawing, everyone has different ways of drawing. So my way of drawing is different from what the other teachers are doing in their schools, what the other tutors are doing. So everyone has a different kind of drawing. So the best way to learn is to look at what you have seen, and then to choose the best type of drawing that you can understand, and then which kind of drawing you're comfortable with, and then you apply that, right? You use that kind of drawing to help you in your solving, right? Like for example, model drawing, many people draw differently. So as you look at your school teachers draw the model, as you look at your tutors draw the model, everyone seems to have a different way of drawing. So nothing wrong with that. Alright, there's nothing wrong with different kinds of drawing, because model drawing is creativity. So you are supposed to draw out your own model. So when you draw your own model, what you need to do is you just need to have a template. Like say for speed distance timeline, there is a template, right? There's a template where you need to be aware of, and then you use a template, right? Use a template to draw out your own model. Alright, so you don't really have to copy what others are doing. You don't even have to copy what I'm doing, right? What I'm showing you is a template, right? A template, and with that template, I create my own drawing, right? That is the way that we should be that's the way that we should be drawing to solve our own problems. Okay, now, so how do we draw this problem? So in all drawing, all speed distance timeline, usually there is a distant line. Okay, there's a distant line, all right, just a distant line, and then the distance line will tell you from where to where, point A to point B, right? That's a distant line. And then you have the people who are moving. You have Mr. Ong, okay, Mr. Ong who is moving. You also have the lorry, which is also moving, and they both started from town A. So I like to use a dotted line to show where they start from. The dotted line helps me to see more clearly. And then in this problem, you can see that who actually left first, who actually departed from town A first. The question never really say who departed from town A first, but the question mentioned, all right, the question said that Mr. Ong passed a lorry that was traveling in the same direction. So if you use a bit of common sense, it means that the lorry must have started first. All right, the lorry must have left first. So the lorry is moving towards town B, and there is an arrowhead to show where the lorry is going. So the lorry must have gone first. Am I correct? And then Mr. Ong must have left later. And because he left later and he's also a bit faster, so he's going to pass by the lorry until here. So what is passing by? The concept of passing by means to be at the same place at the same time. So how do you draw the passing by? You just draw Mr. Ong beside the lorry. Okay, the arrowhead is showing Mr. Ong just beside the lorry, and that is called catching up. That's also called passing by. And I would like to use a dotted line to show they are now at the same place at the same time. Alright, so where are we actually? So we are actually so where did we draw? We draw until somewhere here, right? So Mr. Ong passed the lorry that was traveling in the same direction. Okay, now then how about the numbers? Do we put the numbers inside? Not yet. Right, so this model is a little bit different. You draw out the whole thing first, and then later you will see how to put the numbers inside, which is a bit different from model drawing, right? Your bar model. When you draw the bar model, as you draw, you also put the numbers inside at the same time. But for this speed distance timeline model, it's a bit different. You draw how they move first. Then later on, you put the numbers inside. So there's a little bit of difference, or there's quite a big difference in between this model and between the bar model drawing. Alright, so let's continue drawing. Mr. Ong reached his destination 2 hours later. So Mr. Ong, of course, is faster, and he finally reached. And I would like to draw a dotted line to show where he is now. And the lorry continue to move, and of course the lorry is slower, so the lorry will still be some distance away. Right? So let me just draw a bit nicer. So when you draw your model, try to be neat and don't have messy drawing. Then you can understand your model better. And when Mr. Ong reached the destination 2 hours later, the lorry was still 60 kilometers away from him. So I have the arrow sign to show the distance away. So maybe I can just put down 60 kilometers away from him. So you can put that if you want. Alright? And if the lorry speed was 60 kilometers per hour, find the time Mr. Ong left town A if he reached town B at 4:15. So this is your time that he reached at town B, and find the time he left town A, which is question mark over here. Okay, now so we have actually drawn out the whole thing already. So how do we put the numbers inside? How do we put the speed, the distance? How do we put inside? Alright, this is how you put inside. Now, once you have finished your drawing, you can see that in the drawing there are different parts of the journey. Like Mr. Ong has two parts. Right, the first part is when he caught up with the lorry. So the first part, every part of the journey, there is a set of values. There is a group, right? There's a group of numbers which we call speed, distance, time. Right? There's a set of speed, distance, and time. And then when the lorry continue, or when Mr. Ong continued to travel to town B, there is another part of the journey. So you have a second group, right? A second group of speed, distance, time. And the lorry also has two parts, right? Two parts. So when the lorry was being caught up by Mr. Ong, there is a set of speed, distance, and time. And after being caught up by Mr. Ong, the lorry continued moving. So there is also another group of speed, distance, and time, right? And if I want to have another group of values, which is over here, speed, distance, and time for the rest of the journey for the lorry, I can also do that. So I can have three parts, or I can have three sets of values for the lorry. Alright, so in this model, now you can see that every part of the journey there is a group. Okay, there is a set of values for each part of the journey. So this is what you will learn, alright, when you draw out this model. Alright, then what's the next step? The next step is to now put the numbers into your model. So Mr. Ong traveled from A to B after traveling 3/5 of the journey. So the distance is a fraction. So I can just put 3/5 inside, right, inside the set of values. And after traveling 3/5 of the journey, Mr. Ong passed the lorry, traveling in the same direction, and Mr. Ong reached his destination 2 hours later. So which means that this is your 2 hours later. After catching up with the lorry, he took 2 hours to reach, but the lorry was still 60 kilometers away, which is what you saw just now, right? So the lorry is still 60 kilometers away from town B. And if the lorry speed was 60 kilometers per hour, so let's put down the speed of the lorry, 60 kilometers per hour, and over here is also the same speed, and over here is also the same speed, right? The same speed. So the speed of the lorry is constant, right? It's the same. So find the time Mr. Ong left town A if you reach town B at 4:15. So the model is done. Okay, so have you drawn out the model and have you put everything inside your model? Do you have the set of values for each part of the journey? If you have all these things inside your model, then you do not need to look at the problem. You can just look at the model and you can use that to solve already. Okay, so let's look at how we use the model to solve. So before you solve any speed problem, your teacher will have told you how to find speed, how to find distance and time. So your distance is speed times time. Alright, how do you find distance? Speed times time. How do you find speed? Distance divided by time. And how do you find time? Distance divided by speed. So you need to have the triangle. So with the triangle, you will not get confused on what to do. So if you look at the model, is there any values that we can find? Is there any values that we can find easily? So if you look carefully, alright, now if you think carefully, I can find what time Mr. Ong caught up with the lorry. So 4:15 minus 2 hours, so Mr. Ong must have caught up with the lorry at 2:15 p.m. Right? That is what we can do. And then the lorry was at this point or at this place at 2:15 p.m. as well. Right? Okay? Okay. Alright, and then what else can we do? Is there anything else that we can find? Okay, I can also find how long more or how long does the lorry take to reach the destination. Alright, how long does the lorry take to reach the destination? You can see that over here, right over here, I can find what's the time taken for the lorry to reach. So how to find time? Time is distance divided by speed. So what is distance divided by speed? Okay, so let me just write over here time. Okay, time is equal to distance divided by speed. So you have distance is 60 kilometer divided by speed. So which means that the lorry will take about 1 hour. 1 hour to reach town B. Right? But of course the question never tell me how long will the lorry take to reach, right? So we don't need to find that. But just to let you know that we can also find that if you want. Okay, now, then what else can we do? Now, if you look carefully, you can see something quite interesting. If Mr. Ong take 2 hours, right, take 2 hours to reach after catching up with the lorry, then the lorry must have also taken 2 hours to come to this point, right? Because both Mr. Ong and the lorry took 2 hours to travel, right? And if Mr. Ong took 2 hours to reach town B, then after 2 hours, where do you think the lorry was? The lorry must be 60 kilometers away from town B. Because why? Because the lorry is slower. So the lorry will take 2 hours to come, right? 2 hours to come over here, which is 60 kilometers away from town B. Right? So you put 2 hours inside the set of values and you can find the distance. Okay, let me put the 2 hours correctly. Alright, 2 hours over here. Okay, 2 hours, wrong place. So make sure you put in the right place. So now can you find the distance already? So the distance is equal to speed times time, which is 60 kilometer per hour multiplied by 2 hours, and you will get 120 kilometer. So the distance traveled by the lorry was 120 kilometers. And then if you look carefully, you can see that what's the total distance or what's the distance traveled by Mr. Ong after catching up with the lorry and until he reached town B. You look at distance plus distance. So 120 plus 60, that will be 180 kilometer. So Mr. Ong must have traveled 180 kilometers after catching up with the lorry. Alright, then you look at the set of values again. You can find the speed of Mr. Ong because speed is equal to distance divided by time. So distance and then you divide by time. So the speed of Mr. Ong must be 90 kilometer per hour, and you can put inside here 90 kilometer per hour, right? Okay, then what else can we do? Now, if Mr. Ong has already covered 3/5 of the journey, right, before he caught up with the lorry, then which means that 2/5 must be the rest of the distance. Am I correct? 2/5. 2/5 is the rest of the distance, and if 2/5 is the rest of the distance, then what is 3/5? 3/5 must be 180 kilometer divided by 2, then times 3. So 3/5 must be 270 kilometers. So it means that Mr. Ong must have traveled 270 kilometers to catch up with the lorry. So you can see that I did not really look at the problem. It's all by looking at the model, right? And of course your model must be big, otherwise it's going to be very squeezy and very messy. And what is the speed of Mr. Ong? The speed of Mr. Ong is still the same, because the question never says that Mr. Ong increased the speed or he decreased the speed, so his speed is still constant. Alright, and if I know the speed of Mr. Ong, and I also know that he traveled 270 kilometers to catch up with the lorry, then can I find the time taken for Mr. Ong to catch up with the lorry? Yes, so time is equal to distance, alright, distance divided by the speed, which is 90 kilometer per hour, right? And he took 3 hours to catch up with the lorry. So let me put down 3 hours, right? He took 3 hours to catch up with the lorry. And if he took 3 hours to catch up with the lorry, then what time? What time did he leave town A? Then you look at the timeline, you can see that the total time taken for Mr. Ong to travel from point A to point B is 3 hours plus 2 hours. So it took a total of 5 hours. So you take 4:15, right? Take 4:15 and you minus 5 hours, right? That will give you what time he left town A, which has to be 11, right? 11:15 a.m. in the morning, right? So what time did he leave town A? He must have left town A at 11:15 a.m. So it's actually quite a complicated problem, right? It's quite a hard problem, but you need to know a few things. You need to know your triangle, how to find the speed, how to find the distance, how to find the time. That is the basic thing you must know. And then you need to know how to draw the model, how to draw the speed, distance, time line. So of course, when you learn to draw at the beginning, you will not start learning how to draw like that, right? By the time you are able to draw like this, you should have gone through some lessons already, some of the basic speed, distance, timeline drawing lessons. So once you're able to draw out the simple problem, then you will be able to draw out something like this. Okay, something like this. And this problem is about 4 marks, right? 4 marks. And then you have the 5 mark as well. So, but nevertheless, it's the model, right? No matter how many marks you do or how many marks you are given, it's always about able to draw the model to solve the problem. So over here, what did I show you? I show you that how to use the model to draw out this problem and how to work out the answer. Then how about some of the blanks that we can see in the model? Like for example, there's a blank here. So do I need to know the distance traveled by the lorry? Well, I don't need to know, right? We don't have to waste time to find what's the number there. We don't have to know what time or how long did the lorry travel, right, before Mr. Ong caught up with the lorry. So we don't have to find that. So all the blanks, you can just ignore them, just cross it. But do take note that model doesn't give you the marks. It's the steps, right? The steps that will give you the marks. We call it the method marks. So if you draw a good model, you will still need to use the model to write out the statements. So this is how your speed, distance, timeline model looks like. It is a very comprehensive method. It is a method that will take some lessons to cover. So it's not a simple method, right? It's really not a simple method. You will need to know how to draw from the beginning, how to draw out simple speed problem, and then progress to a bit harder problems, and eventually you should be able to draw something like this. Okay, something like this, and then everything become quite easy already. Alright, it's like model drawing. We don't have to think about how to solve. We just have to draw out the problem and then use the model to solve. Right? So this is the end of our this is the end of the lesson for our speed, distance, timeline. So stay tuned to the next heuristic lesson. We'll be covering a few more methods and then we'll be done. Right? We'll be done with all the heuristic lessons that we teach at MLGs. Alright, so see you in the next lesson.